Hello, fellow mathematicians, and welcome to Blu-ray Maths. So today I'm going to show you the geometrical interpretation of this problem. And before you read the problem, you have to always be careful that if it is a geometrical problem, then you have to keep in mind to construct any line or any diagram that the question says. For example, consider 5 points A, B, C, D, and E such that ABCD is a parallelogram and BCED is a cyclic quadrilateral. So after you read this problem, you should be able to draw some constructions of it. Let L be a line passing through A. Suppose that L intersects the interior of the segment DC at F and intersects line BC at G. So you have two diagrams right now, parallelogram and a cyclic quadrilateral. So as it is considered as a 5 points, consider 5 points, that means it is a single image and it is a cyclic quadrilateral as well. So for that reason, what we have to understand is, first, it is a cyclic quadrilateral and it is a parallelogram as well. That means cyclic quadrilateral only exists inside a circle, and if and only if the 4 points of the quadrilateral meets the circumference of the circle. That basically comes to the conclusion that it must be inside a circle. So for being inside a circle, you have to construct in this way. First of all, draw a circle, and inside a circle draw a parallelogram, but it is not a cyclic parallelogram, it is only a simple parallelogram. So I missed, or I didn't connect the point A to the circumference of the circle. So in the question it has said BCED. So for my easiness to solve this problem, I will just interchange B and D, and after interchanging B and D, it will be quite easy for me to solve this problem and show you the geometrical interpretation of this problem. So for now, draw a cyclic quadrilateral. So find a point in the circumference of the circle, any point in any line in any arc of the circle. Find point E and draw BCED. And this way, you have created a parallelogram and a cyclic quadrilateral at a single image. Now suppose that L intersects the interior of the segment DC at F. So L is a line passing through A. So it passes through A and meets a DC segment of the circle. So as the question says it's a segment, means the image satisfies with the problem or the question, because the DC is a segment of the circle. So the line passing through A meets DC at F. And suppose that L intersects the interior of the segment DC at F and intersects line BC at G. Now as it is a straight line, it will never bounce back like a reflection. It will never bounce back and go to BC. It will move straight from point A. The line L moves straight, goes through the circumference of the circle, and BC can be extended and should be extended because it's not a reflection that it bounces back to BC. So now what you can do is you can draw extend two lines, AF, extend AF line and extend BC line to get a common point G where they both meet. And in that point as well, you can draw one more construction to make this problem more easier. You can draw a particular circle, a circle which touches G, and it meets G, the circumference of the big circle, the dotted circle meets G. Now, to prove that L is the bisector of angle DAB, what you should do is you should prove that angle DAG and angle BAG is equal, because if both are equal, that is bisected, that is angularly bisected. I guess that word is not in the mathematics, but just now I came up with this. So actually it's a bisector of angle DAB. So if it is a bisector, then both angles which are bisected must be equal. The line AG bisects both the angle, that must be equal. So further, there are more geometrical interpretation of this. Let's draw AE and EG and EF. If you want to draw EF, I haven't drawn EF right now, but if you want to draw EF, then you can draw and you can say that suppose EF is equal to EG is equal to EC. That does not make that much difference, but yeah, in my upcoming videos I'll be going to solve this problem officially. And yeah, thank you for watching and have a great day.